let's go on and do the next example. So example number 3, if you quickly skim it, there's actually no equation given. So we have to make the equation ourselves. So it said the length of a rectangle is 2 meters more than the width, and the area of the rectangle is 20 meters squared. Find the dimensions. Okay, so first go with the information that you're given. So first it says that the length of the rectangle is 2 meters more than the width. So that means that the length has to equal the width plus 2. So here's our first equation. Then secondly, it says that the area of the rectangle is 20 meters squared. So our second equation is that the length times the width has to be 20 meters. So we put the pieces of information that they gave us into equations, and now somehow we have to solve for the length and the width. So here we've got a linear equation, and here we've got two variables multiplying. So this can become a quadratic equation. So the idea here is to take the linear equation where it's so easy to isolate for a variable and sub it into the equation that's going to turn into a quadratic. So here I'm going to use substitution. I've already got L by itself. So instead of writing L in this next equation, I'm going to substitute L with W plus 2. So I'm going to substitute this one into this equation, and it's going to become, instead of L, I'm going to write W plus 2. We have times W equals 20. So what I've really done here is I've substituted equation 1 into equation 2. Okay, so let's just simplify from this point here. So I'm going to simplify first by expanding. So I'm going to multiply the W by the 2 and the W by the W. So I'm going to have W squared plus 2W is equal to 20. Okay, and we've had these problems before. Now I got to solve for W. I can't collect these like terms. So let's bring the 20 onto the other side and let's try one of our strategies. So we have W squared plus 2W minus 20 is equal to 0. So the question is, can we factor this? Do we have two numbers that multiply to negative 20 and add to 2? Well, there's 10 and 2, that's not going to add to 2. There's 5 and 4, that's not going to add, and we have 20 and 1. So this is not factorable. So again, we're going to use the quadratic formula. So our A is going to equal 1, our B is going to equal 2, and our C is going to equal negative 20. That comes from standard form. So let's plug it all into the equation. So now I can write x equals, and we can start with the quadratic formula, except take a look and we realize that we don't actually have x, we have w. So I'm going to erase this x. We are solving for w here. So I'm going to write w equals, and then we're going to plug into our equation negative b, which is going to be negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4. Our a is 1 and our c is negative 20. All divided by 2 times a, which is 1. Let's simplify that. So we have w equals negative 2 plus or minus the square root of 84, all divided by 2. So again, we have our two options. We have w1 and we have w2. And w1 is going to come from taking the positive root, so negative 2 plus root of 84, all divided by 2, and we're going to have w2, which is negative 2 minus the square root of 84, all divided by 2. So we have w1 and we have w2. So the two numbers you should get when you plug it into your calculator are 3.58, and the second is negative 5.58. So we have to figure out which one of these makes sense, or do they both make sense? Well, in this case, W stands for the width of a rectangle. The width of a rectangle could be 3.58, but can it be negative? No, because it's a length, and length can't be negative. A measurement in distance cannot be negative. And so what we're left with is this final outcome, which is that the width of this rectangle must be 3.58. if we go back to the question is asking us to find the dimensions. So the dimensions means the length and the width. We found the width, now we need to find the length. So we can find the length from either of these equations, either from here or from this one. I'm just going to use equation number 1. And that says that the length is going to equal the width plus 2. And our width is 3.58. That's what we found out. Plus 2 means our length is going to be approximately 5.58. And so I don't have room for a conclusion, but you guys can write a conclusion. But therefore, our length is going to be 5.58, whatever units it is, meters. And our width is going to be 3.58 meters. And that's our final conclusion. So let's work on the next example. So it says the sum of the squares of two consecutive odd integers is 290. Find the integers. Consecutive odd integers, what does that mean? Well, if one odd integer is 3, the next consecutive odd integer would be 5. If one odd integer is 11, the next consecutive odd integer would be 13. So we need to very carefully pick our variables so that the next integer would be a consecutive and odd. And so if we let a represent an odd integer, that means that a plus 2 would represent the next odd integer. So if our first odd integer is a, and our second odd integer is a plus 2, then now we can create an equation for this, that the sum of the squares of the two consecutive odd integers is 290. So the sum of the squares, so the square root of the first odd integer is a squared, plus the square of the second odd integer is a plus 2 all squared, and it has to equal 290. So I've taken all of the information from here and put it into this equation. So here we actually just had one equation. So the last thing I have to do here is just to expand and simplify. So I know that a squared is going to be a squared plus a plus 2 squared is just a plus 2 times a plus 2, all equals 290. So let's FOIL this. So we'll be left with a squared plus a squared plus 2a plus 2a plus 4 is equal to 290. So I can already see that I have way too many a's going on here. I have a squares, I've got a's. I'm not going to be able to just use simple solving methods. I know I'm going to have to use either a quadratic formula or factoring. So I'm going to bring this 290 onto the other side, and let's continue to collect like terms. So we will have 2a squared plus 4a. And when I bring this 290 onto the other side, I'm going to have 4 minus 290, which is going to be negative 286. Okay, so now I have an option here. I could factor. This could be factorable. Or I could use the quadratic formula. This 286, even if I factor it a 2, I'm still going to be left with a number in the hundreds. And I'm not sure if I want to find two factors that multiply to that number and add to 4. So instead, I could absolutely always use the quadratic formula. So let's use that. So our a is equal to 2, our b is equal to 4, and our c is equal to negative 286. So we're going to sub it into our equation. So we have, instead of x, we have a. So a is equal to negative b, which is negative 4, plus or minus the square root of b squared. 4 squared minus 4, a is 2, and c is negative 286, all divided by 2a. Again, I'm going to work through whatever's under the square root first. So I have a equals negative 4 plus or minus the square root of 2,304 all over 2a. I forgot to say that a was 2, so I'm just going to replace this with 2. So we have 2 times 2, which is 4. So again, we have our two cases. So we have our first case where a is equal to negative 4 plus the square root of 2304 all over 4, and we have our second a2, which is going to be negative 4 minus square root of 2304 all over 4. So the two solutions that you'll get are 11 and negative 13. So these nice numbers indicate that this was factorable and we could have factored it. So this goes to show you could either solve this by factoring or quadratic formula. No matter what, the quadratic formula will work. So we've got to look back at the question and see if we are allowed to take both of these integers of 11 and negative 13. So taking a look, it says the sum of the squares of two consecutive odd integers. So a is just our first integer. We still have to find what a plus 2 is to find our second integer. 11 is an odd integer, and so is negative 13. So these are both acceptable answers. So we're going to actually have two different cases. So the first case is going to be when a is 11, and our second case is when a is negative 13. So I'm going to finish my work up here. So the first case is when a is equal to 11, and our second case is when a is equal to negative 13. Well, if our second integer is just going to be that consecutively odd, so it's just going to be that plus 2. Let's call it b. So I'm going to say that b is going to equal our second number. Then our second number is just going to be 11 plus 2, which is 13. And our second number here is going to be negative 13 plus 2, which is going to be negative 11. So we have two cases in which this is true. The first case is when, therefore, the first number is 11 and the second number is 13. And the other case is the first number is negative 13 and the second number is negative 11. So sometimes we could have two legitimate answers. At this point, you have enough information to be able to work on your homework for this section. Oh.